Good morning, everybody. First of all, I would like to thank to the Icrcet 21 committee for giving me a chance to present a part of my research work here. The title of my talk today is Tailored Manufacture of Chitosan-based composite membrane with silver nanoparticle fillers, preparation, characterization, and antibacterial agent. Myself, Ninyoman Rupiasih, and my colleagues, Bapak Wayan Gede Suharta and Bapak Made Sumadiasa. We are coming from Department of Physics, Faculty of Mathematics and Natural Sciences, Udayana University, Bali. The contents of my presentation today are introduction, material and methods, result and discussion, and conclusion. I start with the introduction. Many studies have been done to increase and utilize the chitosan powder in various fields. One is improving the characteristic of chitosan membranes. Chitosan is a biopolymer which composed of glucosamine and an acetylglucosamine unit linked by glucosidic bonds. It is obtained by deacetylation of ketene under alkaline condition. Ketene is abundant biopolymer obtained mainly from the exoskeleton of arthropods such as shrimp, crabs, and prawn, especially from shrimps, crab, and prawn. Those were always as a byproduct of the seafood industry. Chitosan has attracted great interest due to biocompatibility, high charge density, non-toxicity and adhesion, antibacterial effect, heavy metal absorption, film membranes and nanofiber. Some application. Chitosan film for packaging, particularly as an edible packaging. Chitosan-based membrane used in reverse osmosis, gas separation, dialysis, and pervaporation. It is used as a composite, polyelectrolyte complex, or blend with another polymer. 2. Chitosan still shows some limits, such as weak mechanical properties for many applications, such as low stiffness and high water content. To solve this problem, chitosan composite with polymer or filler have been made. The combination of polymer matrices with nanoparticles that call it nanocomposites that produce a new family of materials which are expected to exhibit better performance, improve mechanical properties, sometimes to provide bioactivity to an inert material. The purpose of this research is studying about the manufacture and the mechanical properties of chitosan nanocomposite membranes by using silver nanoparticle as a filler for a potential method in improving physical properties. Material and method. Material used in this research are chitosan powder, is shrimp-based product by the degree of the acetylation is 87.4%, molecular weight of 900 kilodalton, and solubility in acetic acid is 99.4%. Sodium hydroxide and acetic acid were analytical grade. Demineralized water was used in preparing solution. Silver nanoparticle used is the Sambiloto biosynthesized product with particle size about 10 to 30 nanometer with surface plasma resonance wavelength of 423 nanometer and crystal structure of FCC with lattice parameters of 4.03 angstrom. The nanocomposite membrane were prepared by casting method by using chitosan as a matrix, acetic acid 1% as a solvent, and silver nanoparticle as a filler. Membranes prepared are chitosan membrane 2%, which means pure chitosan membrane that we call as S0, and the nanocomposite membrane prepared were based on chitosan membrane 2% by adding various amount of silver nanoparticles such as 10 microgram, 100 and 1000 microgram. Those membranes named as S1 for chitosan nanoparticle, chitosan nanoparticle membrane with nanoparticle 10 microgram we call S1, and then continue S2 and S3. This is the protocol for the chitosan membrane 2% preparation. This is the protocol for the chitosan nanocomposite membrane preparation. Basically, this protocol is same with the protocol that we have used to prepare chitosan membrane. Just we add some amount of silver nanoparticle in the first step. Okay. Characterization method. For this result, we have measured the thickness of the membrane that we have made, and then also we have measured the pore size and the pore density of the membranes by using the Barrett-Joiniran-Hollanda method, and then also we have measured the tensile strength, elongation at bricks by using dynamic mechanical analysis. And then also we have measured the water uptake capability, Fourier transform infrared spectrophotometer, X-ray diffraction, and also we have done for the antibacterial activity. For the water uptake capability, we have used Formula 1 to measure the water uptake capability of each membrane. Result and discussion. For the thickness of the membranes, we got that the thickness of the membranes is increased as increasing the amount of the silver nanoparticle added. For the pore diameter, the pore diameter of the membrane is increased as increasing the amount of silver nanoparticle added. Also for the pore density of the membranes is decreased as increasing the amount of silver nanoparticle added, except for the S2 membrane. The pore density is increased. Okay. For the tensile test, we got that stress strain curve of each membrane. It's showing in the figure, this figure. From this stress strain curve, we will get the elastic modulus or the Young modulus of each membrane. Also, we will get ultimate tensile strength and then elongation at break of each membrane. This is the result. From figure 1b is showing that S1 and S2 has the highest Young modulus, and then for the tensile strength, the highest tensile strength is showing by S2, but for the elongation at break is showing by S1. For the water uptake, we saw that in this graph is showing the rate of the membrane absorb the water. We can see that at the first 30 minutes, 20 to 30 minutes, the capability the membrane absorb water very fast, and then after that increase gently, and then finally come to the saturation condition. It means the membranes cannot absorb water anymore. And based on this result, we can calculate the water uptake maximum of each membrane, and we got that the S2 membrane has the water uptake maximum, the highest one. Okay. And then for the functional group analysis, we got the FTIR spectra for each membrane. Then we put the functional group analysis in this table. Basically, all the functional group present in the pure chitosan membrane also present in the silver nanocomposite membrane. Okay. Only the position or the wave number of the peaks was shifting. This result showed that it means no new peak form in the nanocomposite membrane. This also will describe that the silver nanoparticle just attached in the membranes, no chemical reaction formed. Okay. This is for the X-ray diffraction, that we got that the broad XRD pattern, the broad peak for the chitosan powder, chitosan membrane, and composite membrane is the broad peak below 30°. This is the broad peak. This indicate the semi-crystalline nature of the major component of chitosan. Chitosan powder show two peaks. At first around 11.81, and then the second one is around 20.75. These peaks correspond to the hydrated crystals and then the anhydrous crystal. Those peaks correspond to the crystallographic planes 001 and then 101. The extended pattern of SG of silver nanoparticle powder is showing that two peaks, first at around 33 degree, and then the second one is around 38.18. For the extended pattern of CH membrane, it means extended pattern for the pure chitosan membrane is the same with the extended pattern of the chitosan silver nanoparticle, that we found that two peak. It means this indicates that the crystallinity of chitosan did not change. Plus, we also have conducted the antibacterial activity test, that we got that all membranes appear to be highly effective against E. coli growth. So there's a clear zone form, okay, as seen in the figure 5, but no antibacterial activity was observed against the aureus bacteria. Okay, we did not see the clear zone form. We come to the conclusion. This study has described about the manufacture and characterization of chitosan-based composite membranes with silver filler, nanoparticle filler, to improve their mechanical properties as well as antibacterial activity. The composite membrane were prepared by casting method using acetic acid 1% as a solvent. The result? Thickness of the membranes increased as more silver nanoparticles added. The pore diameter of those composite membrane S1, S2, S3 bigger than the pure chitosan membrane S0, but the pore density decreased except S2 in increase and bigger than S0. The longest elongation is indicated by S1, the highest value of Young modulus, and ultimate tensile strength are shown by S2. Also, it shows the highest capacity of the water uptake. The diffractogram showed three broad peaks located at 2 theta at about 15.1, 21.2, 23, and 28.9. The functional group observed in the nanocomposite membrane such as OH and NH thread, CH thread, CuC, and metal oxide were shifted mostly to the longer wavelength. The composite membranes has antibacterial potency to the E. coli but not to S. aureus. Based on those results, it can be concluded that by adding silver nanoparticle in the manufacturing nanocomposite-based chitosan membrane affect the physical properties as well as the application of the membrane. Acknowledgement. This work was financially supported by the Ministry of Research, Technology and Higher Education, Republic of Indonesia, under Competency Research Grant of Udayana University, year budget 2020 and 2021. This is some references that we have used during doing the research work, and there's some picture we have taken. And finally, thank you.